sir.
Afternoon to everybody. Am I audible?
Yes, sir, you are audible. Please proceed.
So today I'm to talk about the robotics and drones applications in agriculture. I'm Dr. Narendra Kumar Gontia, Dean and Agriculture Engineering Faculty at Junagadh Agriculture University. Why we need these technologies in agriculture? The reason is major is the labor problems, because the labor problems are increasing. Even the labor is available at the village level, they are not ready to work in the agriculture. The reason is the hardship, the drudgery in the agriculture. And that's why if we want to retain the youths in the agriculture, its mechanization is must. It should be equipped with the technology and devices which are available nowadays across the globe. So many intensive operations are there in the agriculture, like sowing operation, interculturing operation, irrigation operations, and harvesting, post-harvesting. There's so many. These all operations, even in interculturing, suppose the spraying of the fertilizers, the spraying of pesticides, weedicides, and all these things, all operations. Any operation you take that needs a lot of drudgery and lot of efforts a farmer or the labor has to do. That's why the labor are migrating, though the number of laborers is increasing in India. Earlier, 26 crore labor were working in the agriculture, which has reduced to around 20 crores only, though the total number of labor in India increased from 36 crores to 46 crores. So the additional labor which has increased, they have gone towards the mega cities and particularly the construction of high-rise structures and those road and railways and all those things. So this forced us to go for these technologies which are necessary for the agricultural operations to be automated. This, what I have already talked, what is the impact of internal migration from rural to urban migration. The particularly widespread unemployment, rise of squatter settlements, overcrowding, unhygienic living conditions, strain on urban facilities, and rising crime rates. What happens actually, the rural labor which is migrated to the urban areas, they lives in slums only, and their standard of living reduced like anything, and they are if they get affected by the surroundings, then the rising crimes and other things are increasing. The other side, if you go in rural areas, you find depopulation, women take on greater share of farm work, declining farm productivity, social problems, single parent families, so many problems they are come up. And that's why the number of women in labor contribution is increasing in India. If you see the robotics potential in agriculture, these are the areas where robotics can work. The autonomous mowing, pruning, seeding, planting, sorting and packing, monitoring, scouting, thinning, milking robots, cultivation, tractors, irrigation, crop monitoring, weed control, harvesting and picking. All aspects, if you see, almost all the aspects of agriculture where robotics has their potential, and slowly they are substituting the labors in Western countries. And so what, why not in Indian agriculture also? In future, I am saying the things will percolate in Indian agriculture also. May not be that fast that is going on in the Western countries, but it will percolate in Indian agriculture also. Now, where the robots? Robots is the branch of technology that deals with the design, construction, operation, structural depositions, manufacture, and application The robots are designed or integrated with a specific task in mind and tailored to meet the unique needs of the task. Suppose this what photographs I am saying, these are the robots are designed for the interculturing operations. So they are trained for particular crop, that this crop is the main crop or major crops, except that crop, whatsoever the plants are available, they are considered as the wheat, and the robots will do its exercise. They will pick up that wheat and they will go for the weeding operations. So these are some things. It's the agriculture purpose where robots are used in different. Now, how harvesting robots work? There are different robots, as I told. This is one is weeding. The fruit harvester robot is able to locate and pick ripe fruits. Particularly horticultural crops, the height is a problem. The person has to go on the tree. There are certain problems also. The possibility of some damage to the person, that is also there. These robots are easy to utilize, and they will pick up only the particular ripened fruits only. They are trained in that way that they will find out or identify the by color and texture. They can identify the fruits which are ripened, and those fruits they can take up. So the eye scans are used for plant to determine the number and position of ripe fruits. Image processing algorithms also. These are the detect ripe fruits. These are the devices which are used to operate or to handle these robots, or to take the proper work from these robots. Now, using the four-fingered prosthetic hand locates a fruit, opens the fingers, and takes hold of the fruit. The robot balances, pulling, bending, and torsion movements to detach the testicle trees. So these are different the operations which are possible from the such robots. It can pull, it can bend, it can torsion movements, or detach the testicle and by any force of such type. Now, major robot application, as I told, is in a plant training system, machine vision system, and machine vision system for sunlight fluctuations compensation to detect tomato and flower clusters and like that. These are the different robotic systems which are in general used nowadays in advanced agricultural farming in Western countries. Tomato fruit cluster, suppose I have given one example of it is used in Japan generally. So because the tomato is grown in a cluster, so individual tomato is not detached, but the whole cluster is detached from the plant, and it is taken. If you see the example over here, the whole cluster is taken up, and then the ripened fruits taken up from there. This is cucumber harvest and detector, how it is used. They cut the stem from the branches, and they pick up the fruit and take in the basket. Sweeper robots are used. There's a sweet papers. Average time to harvest one fruit with sweeper is between 18 and 25 seconds only. So you can see how fast these robots can work, and that also with very precisely, which is not possible by a human being to do it so fast and so precisely. So the losses are also less. On the other, efficiency is also high. It's an assembly of an autonomous mobile platform with phonic alarming 200 IT robot manipulator holding an end effector and catching devices for fruit harvesting. So these are different devices which are used for the harvesting purpose. In Europe also, the WP5 uses robotic arm with a gripper to cut the sweet paper fruit. So different the fruits, different types of robots are used. There, as I told, their mechanisms are different. Some is twisting, some are cutting, some are pulling, like that. So according to the requirement of the fruits, that type of mechanism is used in the robots, and the robots are utilized. Too many cameras and other sensor technology attached to the gripper help to detect the fruits. So these cameras, as I told, there are cameras, there are remote sensing devices which take the images of the fruit first and then take the decision whether it should be ripen or not. And once it is confirmed that it is ripened, that will be harvested. So the robot is configurable, modular, and intelligent. All the three things are possible from a robot. So you can configure it for certain fruits, and you can modulate it, and it takes its own decision also intelligently to get the better efficiency and the good fruits also. These are another type of robot based on leaf area index and height. Here also it is used in Korea. So these such types of robots, they are used for leafy vegetables mainly. In 6 seconds per plant, they can take. So again, the leaf area index, as we know, as good is the leaf area index, as good is the plant. So leaf area index types of robots are used for leafy vegetables harvesting, and they are useful for such technologies. Then autonomous precision seeding and nursery planting. This is also an area where robotics are used to manipulator, as a eliminator, as a vertical slide, and computers and control electronics is used to control the such types of robots. And a nursery can be totally managed by such type of robots, and with minimum labor requirement, we can manage the bigger nurseries. Similarly, robotics is spray for greenhouse. And greenhouse spraying is a big problem. So such types of robots, they are where they can spray on the plants, whether it the liquid fertilizers or the pesticides on this such type of spray can be made regularly on the plant. So tracker mechanism is used for tracking the path of such robots, and it is utilized in the greenhouses in a controlled environment. Overhead pesticide sprayers, such are the sprayers used in very advanced greenhouses, which if it's a big greenhouse where you have to do the work within limited time, such type of pesticide sprayers are used. Then weeding robots, as I've shown earlier also, such type of weeding robots. There are two types of weeding robots. Suppose here the wheel drive weed seeking robot. So this type of robots, they can go for the tillage operations. So it can work in twice way. One side it uproot the weeds, on other side it will pull the soil towards the roots of the plant which we want to grow in that area. So this is another operation which is possible through the robots weeding operation. Hortiboard in Denmark, horticulture people, they are utilizing such robots, recognize 25 different kinds of weeds and eliminate them by using its weed removing attachments. So we have to train such robots for those plants, around 25 plants as at present level. In future it can increase also. So such type of plants, they can pick up and go for better weeding operations and provide a better environment for the major crops to grow up. This is another eggbot. Second, in Australia, it is used autonomous field robot platform for individual plant phenotyping. So this autonomous fertilizer application, weed detection and classification, and mechanical or chemical weed control, this used for the several operations. So such type of egg boat, they are used in Australia. So where they can perform multiple operations as you modulate to them. Automatic vegetable grafting machines. No, grafting is another area which not only required the labors, but precision is also required in grafting. And earlier grafting was done only in the trees, earlier trees and shrubs, but slowly now grafting is used for the small vegetables even, which is very precise, and we have to take care of everything. So if you do with the automatic vegetable grafting machines, they are also robots, small robots. So they have 95% success in this, and better than human efficiency they can work. And you after grafting, we can get better production to the vegetables and such, particularly the vegetables grown in India like brinjal and tomato, and these can we can go for grafting of such vegetables. Watering robots. See, watering is another, particularly when the plants are grown in controlled environment. Applying water to each plant, that is also a very specific requirement. We do go for this using the drip irrigation also, or the sprinkling, or robots can be used where robot can apply water in each and every pot only, and for its requirement of the plant. So these robots have both the things. They can take the requirement of the plant also, they judge that thing, and then supply the water also. Combined vegetable grafting machine, as I already have told, in Korean countries, and they are using such grafting machines, which is ultimately a robotic only, which for cucumber, for tomato, for brinjal, such vegetable crops, and they can do the operation very precisely. MIT robot gardens in United States, a mobile robot can maintain the soil humidity and pick the ripe fruits. A network of sensors attached to each plant monitors the soil humidity and call the robot for water. The robot communicates wirelessly with the plant sensors. So every robot, as I told, it has equipped with several types of sensors and devices as per the requirement, and it do the specific work. That is the only problem, that each and every robot has its specific work only. You cannot take other work. Slowly, the multitask robots are also developed. As I shown in Australia, they are using the multitask robots also, but very costly machines, and they can do the specific works only. So though it replacing the labors, but the cost is more. Naturally, till now they are mainly used in the controlled environment agriculture, where it is grown in greenhouses or in the net houses or vertical farming. There the robots are introduced at the first level. Automatic sorting of multiple quality attributes. This is also a plant in USA where high-tech sensors, very fast response they are giving, and fast accurate segregation based on preset quality parameters. You measures 40 fruit per second per lane. So this is its capacity, very high capacity. It may replace even 10 to 15 labors if we do manually. So in such type of high number of fruits, in crores of fruits, individual fruit per 20 hours per day for 10 lanes, they can perform the operations. Then PRO packing robots. As I told, a robot has its own utility in all aspects. Till now, we have seen the robots which are used in plant thinning or plant weeding or plant interculturing operations or irrigation or harvesting and like that. Now, there are few robots which are used post harvest operations. After harvesting the plants, there are so many operations are required where labor is required and precision also required. We can use the robots, and in India, robots are coming faster in the processing industry than in the means nurturing or nurturing the plants. So I think this is the area where robots are coming faster in comparison to the field work. So these are the packaging robots. You might have seen the packaging machines nowadays available in the market also. So those machines, they are equipped with the robots now for more precise work, and the machinery with the camera programming and different types of images they can take, and with the images they can take means that packaging is not only simple packaging, but suppose there are three types of apples. One may be green, one may be mix up of green and yellowish, and some is brown, like that. So they can pick up the different according to their color, their texture, and they can fill up the different packets, and then sorting out the packets also. That also they can do. So automated palletizing tasks can be done, smart enough to detect the type of cargo stack, divides and stack boxes on applicable pallets. All work a robot can do, and replace the lot of labor from that area with better efficiency. Bee boats robots. See, this is another area. We are using so much of pesticides, so much of weedicides, and bees, as we know, the bees are the friend of agricultural phenomena. All agricultural operations that we are doing, but one operation is that the spraying of the particularly for the plants, all the plants for their propagations, the bees are helpful. So those bees, they die because of this too much use of pesticides and fertilizers in the area. Now the bees population is somewhere it is reduced, and somewhere it is almost there's no bees are available in that area. So even the artificial bees, they are also one type of robots only. So bees are manufactured now. This small flying robot is inspired by bees and used for pollinations. Different plant pollinations is possible for propagation of the plants. So this is another area due to the human problems, or due to the pesticides and other uses, due to reducing the population of bees. Now, in particular, few plants where pollination is possible through bees only, we can use such robots, and they can help the farmers to go for pollination of such type of plants. Self-directed tractor robots. Now, earlier we have seen the tractor drivers were replaced, and we have gone for the driverless tractors. Now, instead of driverless tractors, now tractors are designed which can be operated by robots. Because the tractorless drive, it is not only the driving. In tractor case, it is slightly different as compared to the motor vehicles. It is not that you have to only drive the tractor. I mean, say driverless tractor is not sufficient. We have to take some decisions also somewhere, how much depth is to be applied, how much, where to take the turn, and how the pulverization, more pulverization is required, or somewhere the roots are there. So if it is stuck, then we have to release some hydraulic systems, and all these means so many decisions as to it. That's why it's in the, we don't say the tractor driver, we say the tractor operator, because he has to operate so many functions. So now the tractor robots are available, which can operate the tractors, An escort showed the prototype of India's first electric tractor, the Farm Track 26C. The 26 horsepower diesel engine is that tractor is a robot operated tractor. So in India now, it has just introduced by the escorts. Electric automated tractors, they are also, Mahindra has given the autonomous tractors where a small function is used with robots. It doesn't mean a machine which has big or there. It can be a device used with the tractor, because as I told, robots means which is design, a device which is designed for, which can take its own decision. It can be modulated. It can be trained for certain work. If it is there, that's a robot. It can be equipped with a tractor also, and it can work. And Mahindra is also, they have a autonomous tractor, and they have launched it first time in India. Now, as till now we have seen about the robots. Similarly, the drones. Drones are also very fast. I think drones are coming faster than the robots. Robots came earlier, but they have not penetrated as fast as the drone came late in agriculture, even in other field also. But they are penetrating very fast and they are utilized very fast. Their applications are increasing. The reason is the drones are not so much costly, but they are replacing a lot of labors in comparison to robots. Very precisely, they can do the work. Suppose particularly when we talk about agricultural field soil analysis, widespread seed planting, crop health monitoring and surveillance, spraying of inputs, irrigation and monitoring, crop damage assessment, and livestock tracking. These are the several, they are long list where the drones can be utilized very easily, and even a small farmer can do that his work. Or on contractual farming, if some educated youth from the village, he can purchase a drone, he can go for the on the contractual basis, he can do the work of whole village or nearby cluster of villages. So the drones applications are increasing in these areas. As I've told, maybe it is a soil analysis work if you're doing, because a soil health card is developed by the government of India, a big work. There also we can use the drones for the soil analysis work. Then seed planting. See, in forest, in areas where by spreading only and seed plantation is to be done, their drones are the best. So you can utilize the drones and go for plant spreading, and seed can be spread over the large area by a single person. Then crop health monitoring and surveillance. This is another area. If these robots have the sensors or the image sensor, we can say, which can take the images in different bands of, and those, based on those bands, we can find out that we can easily find out that what is the condition of the crop condition at that area, whether the crop is required water or irrigation, or the crop is susceptible to some pathological bacteria, or it is affected by some pests or something like that. That everything, it can be detected through such drones by those images. Then spraying of inputs. So as I told, the spraying of pesticides, weedicides becomes very easy now, because each drones may be having 10 to 20 liters of capacity of the tank. A payload capacity is nowadays up to 20-liter payload capacity. The drones are available. You can use the pesticide and you can go for the spraying operation. Irrigation and monitoring. This is the area where slowly going may takes time, because the capacity of payload capacity is not so big. So only fertigation and other things till now. Monitoring is possible. Irrigation monitoring we can do, and we can operate the drip from the ground as per the decision taken by the drones. Crop damage assessment. This is another big area. See, today only there is a cyclone in Saurashtra region from where I am taking this. So a lot of area is affected due to cyclone and winds. Now, how much is the loss or what is the damage occurred to the crop and plant and horticultural crops and like that? A government has to take all the assessment within few weeks, which is very difficult to take through the labors. And such drones and these devices, they can go very fast, assessment can be done, and government can take decision that where they have to supply what and what is the they can help to the farmers in such situations. So in such conditions, the drones are very much useful, whether it is a drought, whether it is a flood, or whether it is a cyclone. All in such conditions, a assessment is becomes easier and faster. Livestock tracking. In India, generally, we don't have such requirement. Livestock tracking is not in foreign countries where livestock are in a large scale and one person is having in those, here it is used. But even though in some where it is required, we can use it for tracking our livestock, where it is going and how we have to divert it. This is some operations of agricultural field soil analysis which we did using the drones, and 2D and 3D maps are I am showing over here for the depth to this is root zone capacity map, compactness map, phosphorus soil map, depth to root restriction map. These are possible through the drones. Similarly, crop health monitoring and surveillance. So such drones, if you have the camera in images, different band images, it can take and it can give you the NDVI values, SAVI values, remote sensing. Those who know the remote sensing, they know with these we can get the idea about the crop, that what is the present condition of the crop, how is the health of the crop. It can be easily taken from such a remote sensing based cameras. It can be attached a payload in a drone. Similarly, crop health monitoring and surveillance, phantom type of cameras. Cameras are available with these drones, these small drones with half kg or 1 kg payload capacity, and they can take the images and we can get it out. Spraying of inputs. So for such, we need the heavy drones which have capacity from 10 liters tanks to 20 liters payload capacity, and we can fill up. One thing is the technology is advanced. We have to go advance in such a spraying technology. Naturally, we need some nano technology based the spraying material also. So in a small quantity, we can cover a larger area. So the capacity of payload capacity may be less, but it can cover a larger area. So that is also a requirement of today's world, that we should go for nanotechnology based materials, which is in a small quantity, we can cover a larger area. See, it is not only the spraying that we can spray at faster rate, but we have the whole control. We can these drones, we can then program them that where to spray, where not to spray, how much to spray. We can maintain its concentration also. Somewhere higher concentration is required, where more pests are there, higher concentration, somewhere lower concentration, somewhere there is no pest, so no spraying is possible. All you can program, and with that program the drone can be piloted by the pilot, and it can work accordingly, and we can save a lot of pesticide. It will not only save cost, but it will save the environment also. So unnecessary pesticide, and as I told earlier, the bees are dying because of the so much of pesticide we are throwing on the crops. So if we use limited pesticide, which cannot affect much on the environment, so that will be good for the human health also, and for the health of the other animals also. crop damage assessment, as I told, whether it is a flood affected area, whether it is a drought affected area, whether it is cyclone affected area, any type of natural calamities there, we can go for assessment of on a larger area with small, very small or limited time. We can track the whole area and we can get the images, and based on the images we can take the decision that what is the situation in that area. So this is something from my college labs. Our students, they are using the robotics and automation laboratories. They are the youngsters, they are trained in these technologies. So you will see in coming 5-10 years only, these robotics and drone technology will enter into the agriculture like anything. And these guys who are youngsters, who are getting the knowledge of such latest technology, they will go in the field and help to the farmers to bring the automation in the agriculture, and they will bring the agriculture in such a way that the youths can be attracted in agriculture, and they can do better agriculture and farm with automation and serve the country. These are different small drones for giving them pilot trainings and how to pilot the drones. So this is different types of drones which are used in labs for training the students. These are drones used for dismantling, so they can understand the different parts of the drones, how the drones are working and what are the different components of a drone, and some problem is there, how to repair that. Hexacopter, see, there are several types of drones. They are the 4 wings, 6 wings, 8 wings, like that. Suppose this is a 6 wings hexacopter drones, we are saying its capacity maybe 10 to 12 liters. Now there are quadcopter also. So quadcopter, the capacity slightly low, but as you go for higher wings, the stability is better. In comparison to suppose quadcopter, the hexacopter have better stability, and you can spray properly with this. DJI Phantom drones, such types of drones, as I told, it is used more for surveillance purpose. They have half to 1 kg payload capacity, so only a camera can be loaded on that, which it can take images in different bands, and we can go for surveillance of the area and survey of the area, and can get the decision. We can take decision based on this surveillance. The visible and multispectral camera, as I told, this is the same thing for those the students are working for the surveillance, and similar things. Different students who did the projects on these aspects. So these are the future projects we are doing. It is not that only the trichoderma and other things, chlorophyll cornea against lepidopteran pests. We can use such types of drones, and we apply the different types of such on a particular plant or particular place where we want to use that. So that type of work is going on, laying the legs in the such type of reservoirs has kept, suppose, in different places on a field. So how to lay the legs? Yep. At present, every the person is going and laying the leg in each tough. Now, if we have drones, we can use the drones for laying the legs in the troughs, which are distributed all along the big fields. So this is all our own experience with the robots and drones, what we are using over here at our College of Agriculture Engineering Technology, Junagadh Agriculture University, Junagadh. Thanks. I think it is the way forward. One thing, encouraging investment and projects in infrastructure is must. A lot of investments are required. So the new entrepreneurs which are coming, they should think about that and go for the investment in this area. So in future, The things are available not only from the European countries or Western countries. We can import the such devices, but we can have our own. We can say what is we are calling the Making India. We have to go for that. Then partnering with private industries. Suppose we ourselves, what we are doing the research, we have to partner such research with industries, and we can collaborate to each other, PPP mode, what we call, and get accelerated the work. Developing integrated flagship programs such as Nachi Area of Excellence, encouraging the custom hire service. This is very important. Each and every farmer cannot purchase every device, but a educated agricultural graduate can go for a such type of business. He can purchase such devices, keep at it home. Nowadays, the mobiles and other applications are available. The farmers can contact him and he can send on hire basis and do the work of farmers. So farmers also get on hire basis that device they can use, and that such agriculture graduate they can also get the employment. So this is called that how the self-employment is possible in this area. Extensive research and basic data are required for Indian conditions. As I have told, maximum robots, suppose I have shown they are used in Western countries only. Indian conditions also, we have to use them and we have to develop the data. So protocols required for the drones also. Drones are coming very fast, and we are also trying to develop the protocol for the spraying and other things for the different crop wise with the different types of drones. So such extensive research is required to be done by the universities and the academia to help the farmers. Thank you.
Thank you very much, sir, for a wonderful presentation. I will take up the questions from the participants now. In the meantime, can you please stop sharing the screen, sir, so that we can see your full video?
Yes, please.
Yes, sir. Thank you very much. I'll take up the questions now. What type of sensors and technologies are commonly used in agricultural drones for data collection and analysis?
Yeah, data collection. See, as I told, what type of data? See, every task is a specific task that I told very first. It is not that any robot you can use anywhere or any type of technology. So suppose one technology I have told is remote sensing based technology. You can use this. They are called sensors also. You can say image cameras also. So they are sensors which can sense the crop or anything which is exposed at different bands. So suppose red band, near infrared band, blue band, green band, like that, or short wave band. And nowadays even the other devices available, but micro level even bands are available. Microwave bands are available. So in these different bands, the sensors can sense or take the images, and those images are then analyzed. Analysis also different types of analysis. We have to go for image processing. There are several indices are used. Those indices we have to find out. Means every operation, as I told, is a task, is a fixed thing which certain types of sensors, a very skilled persons are required for analysis. It is not so easy. That's why I told the agricultural graduates and graduates from the electronics and computer sides, they all are required to be there to go for such operations and make such drones or the robots which are task specific, and their analysis is required on computers with all types of softwares to be used, whether it is remote sensing processing softwares or GIS and other softwares we have to use for such operations.
Okay. How can robotic systems and drones help in early detection and management of crop diseases and pests?
One thing I want to ask you, madam. I think only 2 participants are there.
Sir, the meeting is being live streamed in our website, sir. So
No.
participants are logged in our website and they are listening to your talk there. They are
Yeah.
posting queries there. I am reading out those questions for you. You
So
cannot see participants in
what
Zoom, sir.
questions you are asking is your questions or participants' questions?
So some are from our editorial team and some from the members.
Achha.
Okay.
So now please go ahead.
Okay, I'll read out the question again.
Yeah, please, your question, please. Can you repeat the question? Hello,
Yes, sir, I will repeat
can you
it.
repeat the question?
Yes, sir, yes, I will repeat it. How can robotics and drones be used to improve crop monitoring and yield estimation for farmers?
Yeah, see, nowadays, suppose I give a simple example here in Saurashtra, the white fly in coconut, the white fly is spreading like anything earlier, and government was taking actions in part, means only giving suggestions to the farmers and that farmer take action on his field only. Then we have suggested that this thing cannot go till you will not take a big area monitoring and get idea that where the white fly is spreading and how fast it is going. The government has to give this task to some organization and get it fast to take decisions. And in some area government took, in some district they took the decisions and they have monitored using the drones, and they found that it is spreading very fast and such, and government has given the spreading of the pesticides from government sites based on the, and such areas they have got success also. But where the scattered spraying is going on, still we are not able to control the white fly. So such things are possible if some widespread pests are coming which are affecting a large number of crops, and there we can take fast decisions. We can get the estimation that how much area is affected and how fast it is spreading, and what government should take the decision. Whether a farmer is able to do that, the individual farmer is doing, then the surrounding farmers, his neighbor is having the same problem, it will again come to his field after 10 days or 15 days or 1 month, when the pest is exhausted, pest effect is exhausted. So this is something where such technologies can be useful at a large scale.
Okay, I'll move on to the next question, sir. What are the cost savings and efficiency improvements that farmers can expect by adopting robotic and drone technologies?
Yeah, I told very earlier that at present cost saving is possible only and only if the custom hiring, if we can go. Individual farmers is difficult, they cannot purchase such technologies their own, and if they can use for their own farm, because in India the farmers are hardly having 2 hectares of land, 1 hectare of land, half hectare of land. A big farmer is also maybe 10 hectares. Such technology is not advisable for small farms. But yes, if a highly educated youths which are available at village level, if they want that they should develop their own entrepreneurship, they can go for custom hiring. They can purchase few such devices which are useful in that area, which is needed in that area, and go for custom hiring. So as I told you, if the mobile app and other things are available, the farmers can ask through the mobiles that you send such and such devices I need for 1 hectare, half hectare, like that. And they're in few states like MP also, it is custom hiring is successful. More than 10,000 the graduates are, they have opened there, and government is giving the subsidy for purchasing different types of, not only I'm talking about the drones and robotics only, but they have been given subsidized tractors and farm implements and post-harvest devices, which they are using on custom hiring to the farmers. So such, based on that only, such drones, and drone is started in Rajkot here in Saurashtra. In the Rajkot, there is one company, Bhumi Agro. They have started giving drones and custom hiring for the spraying of pest and pesticides. So such things are possible. Slowly it will come. Madam, the major problem is labor. Even the labor is, as I told, labor has increased from 36 crore to 46 crore. 10 crores additional labor is included in the last 10 years in India. But that labor from agriculture sector is reduced from 26 crore to now 20 crores, 19 crores maybe. It has reduced in agriculture sector, though the 10 crores in increase, but in agriculture sector, 7 crores labors are reduced. It is going in other sectors, particularly in mega cities and big cities and urban areas where the construction works and other things, they like to do that work instead of drudgery work of the agriculture. So the farmers get advantage only and only when such things are available on higher basis.
Okay. What are the potential environmental benefits of using robotic systems and drones in agriculture?
Yes, I gave you very simple example that the farmers are using the pesticides at a very large amount of pesticide unnecessarily used in a whole area. Suppose he has 2 hectares of land and only half hectare is affected, he may be spraying whole area. So using the drones, you can survey the area, you can get the idea where is the pest, how much it is affecting, where we need more pesticide, where we need less concentrated pesticide, where we need no pesticide. So we can immediately program the drone accordingly. The drones are programmable. You can put up the whole program of the whole area on through the GIS. It is governed through GIS and GPS system, and as it goes in the whole area, it will spray where it is required and how much it is required. That much only it spray. Other area it will not spray. It will remain dry there. So the requirement of pesticide is reduced like anything. Maybe it is 1/4 or 1/5 only, or maybe less than that if 1/10 also, if a proper programming is done. And on the other side, hello?
Yes, sir. Yes, sir.
On the other side, as I told, we have to develop some other things also. If you are using drones, go for nanotechnology, I told. All pesticides and fertilizers, nanopesticides are required. So very small amount can be spread on a very large area. So it can serve both the purpose. The input cost is reduced. Other side, we can save the environment also. The pollution through these pastes and fertilizers and that can also be reduced. See, maximum pollution in India, we can say greenhouse gases we are saying, because we are using too much inputs, whether it is a fertilizer, whether it is pesticide, too much input we are using, and that's why the green gases are increasing, particularly the paddy crops, and that lot of water we are using, always we submerged and methane is produced. These all possibilities are there if you can go for the advanced technologies. And that, see, when I was a student, I was reading the drip irrigation only in books only. Now it is a reality on the field. So what we are teaching today, or what we are trying to bring today in research, tomorrow it will be reality on the field, because that will be the requirement of the time.
Okay, I'll move on to the next question, sir. What are the challenges and limitations of implementing robotic and drone technologies in agricultural practices?
Yeah, the challenges, as I told, is one very first challenge is that our customer, which is farmer, is very less educated. We have to give trainings to them. We have go for capacity building. Another thing, their holdings are very small. Small holdings are there. They cannot afford such technologies. But on cluster base, suppose FPOs now, government has introduced FPOs. The FPOs, these food processing organizations, suppose they can have a plant. They can have the robots for the separation of the different types of fruits and their packaging and all these things. So they can have the such type of robots they can purchase and they can use in their plants where the 300 farmers or 400 farmers can be the member. Only thing is they will supply their fruits and vegetables at that area, sorting of fruits, cleaning of fruits, their segregation and their grading and other things that will be done through these such type of robots. It is possible in future. So the only thing is system is to be developed. Without system, how in other things, nobody, everybody is not purchasing a car, everybody is not purchasing a bike, but the buses are available, a public transport system is available. The similar system is to be developed in agriculture also. It is whether it is by the government or the private organizations. I hope and believe what the government did with the 3 acts of Farmers Act, what the government brought earlier, where the private players has to be allowed to go in the agricultural field. That was a good decision because government cannot go for everywhere to do that work, and farmers are not capable to do that. Then who will do? We will need the entrepreneurs who will, whether they are young entrepreneurs or big players or whatsoever they are, they will put money. Every business, everybody can put the money and develop that business. So why not agriculture? Particularly marketing, processing and marketing and packaging, transportations, cold chains, and all these things can be developed faster if we allow the private investment in that. And it is the need of the hours.
Okay. How can agri entrepreneurs leverage robotic and drone applications to improve productivity and create innovative agricultural solutions?
Yeah, as I told, suppose a robot, weeding robot, suppose let us take one example, weeding robot. It is, as I told, very precise, 95% precision is there in weeding robots. What today they are used. Tomorrow the technology may improve, even it can go better precision. So the plant get better environment. The competition will not be there among the plants. So naturally, the growth will be better, the production will be better, supply of inputs is possible to the drones, as I told, where it is required, how much it is required, that much only will be supplied. So input cost can be reduced, the efficiency of plant growth is better, input cost can be reduced, that everything will contribute towards the production, productivity, and the profits, obviously.
Okay. Thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Dr. Narendra Kumar Gontia for the talk and for answering the questions. I like to also thank all the participants in the meeting. This meeting will now be closed.
I want to know that much. Again, I asking questions. How many participants are there? Can you?
Sir, that will not be knowing, sir. We have to check in our back end. We have to check in our back end, sir.
You have asked so many questions. I'm also giving you
some questions were from our
I'm also giving you a task. Please give me the reports that how much it is affected and how many people have got the advantage of this talk.
We will check in the back end. And
that feedback I want from you in my
Okay. We will let you know.
Okay.
Thank you very much, sir. Okay.
Thank you. Good afternoon.
You're welcome, sir. You're welcome.
So I'm leaving.
Yes, sir. Sure, sir. Thank you.